Thank you for watching this video. Today we are going to have a recording on the working principle of reciprocating pumps and the power developed by a single acting pump. Thank you and enjoy. Now let us look at the introduction. What is a single acting piston pump? This is a positive displacement pump, and it delivers fluid in pulses in every crank revolution. It has the following main components. We have a cylinder, a piston that is connected to a piston rod. You have a connecting rod whose function is to transmit, or rather to change, the rotary motion of the crank to the reciprocating motion of the piston. We also have the intake and the delivery valves. Apart from that, we also have pipes that are used to deliver content, in this case fluid, to reservoirs or any other source of use. Now, in the next slide, we are going to see components of a single acting piston pump. So, we have delivery pipes, as we had already discussed on earlier on. We also have a cylinder, whereby inside the cylinder we have a piston that is connected to a piston rod. The piston rod is also connected to a connecting rod, which is connected to a crankshaft that is the sole or prime mover of the piston pump. The crank goes in a rotates in a rotary motion, while the piston moves in a reciprocating motion. The connecting rod, as you can see, is changes the rotary motion of the crank to the reciprocating motion of the piston. Now, let us look at the next slide, where we are going to discuss on the working principle of a single acting piston pump. So, a single acting piston pump works in two strokes. The first one is the suction stroke, whereby the piston moves outwards due to crank rotation, and so a vacuum is created inside the cylinder bore, and since we have a negative pressure which is created by the vacuum, thereby suction of fluid takes place due to a higher atmospheric pressure acting on the water or fluid beneath. Fluid enters through the cylinder bore through the suction valve, while the delivery valve remains closed. During the delivery stroke, the piston goes back, and we refer to this as the return stroke. Now we have fluid content inside the cylinder. The content is compressed, and as a result, the fluid pressure increases. As it increases, it causes the delivery valve to open as fluid is pushed out of the cylinder bore through the delivery valve, while the intake valve remains closed during this stroke. Here is an animation showing the working principle of a single acting piston pump. Let's have a look and see how it works. Now, you can see we have a suction valve. The piston now during the suction stroke is moving outwards, and fluid is allowed to enter through the cylinder bore. Then during the return stroke, you can see the fluid moving outside through the delivery valve. So remember, we have creation of a vacuum pressure which causes intake to take place inside the cylinder, and as a compression takes place by the piston going back, therefore pressure increases inside the cylinder bore, and fluid gushes out through the delivery valve. I hope that animation was helping and had a good idea on how a piston pump works. Now, in the next slide,
allows the water to flow inside the cylinder. During this time, the delivery valve remains closed. As the piston starts moving towards the left, the suction valve closes and the delivery valve opens. Due to the pushing action of the piston, the water goes out from the discharge valve to the delivery side. This is how the single-acting reciprocating pump works. But with this type of pump, there is a drawback. That is, single-acting pumps discharge on either the forward or return stroke of the piston or plunger. Every cycle of the pump displaces only one volume of liquid. As you can see during the suction process, there is no delivery of liquid at the discharge side.
We are going to look at the power developed by a single acting piston pump to discharge fluid running at n revolutions per minute. So, what is power? We can define power as the rate of doing work. According to Newton's laws of motion, work is the displacement moved by a certain force. Example, the movement of a piston inside an automobile engine is a good example of work. Okay, now what is discharge? Discharge is the volume flow rate, and its SI unit is given in meters cubed per second. Now, how do we derive the volume? Volume can be derived as pi r squared times L, or rather volume of a cylinder is given by cross-section area times height. Now in this case, L is the height or the stroke length, and D is the cylinder diameter. So we can have the formula as pi r squared times L, or pi d squared over 4 times L. Now let us define what is density and how is it going to help us. Density is the ratio of mass to volume. Okay, now we want to define weight, but in order for us to get weight, we have to know the mass. Then we multiply by the gravity acceleration. Now if you put the mass to be the subject of the formula, then we are going to have mass as a product of density by volume. Okay, now once we have the mass, then we multiply by gravity, and then we are going to get the weight of the fluid that is going to be displaced by the single acting piston pump. In this case, we have the weight given by gravity times density times volume, which in this case is pi d squared over 4 times L. Okay, now this is the weight of the fluid that is going to be displaced. But what is the displacement distance the fluid is going to be displaced? Remember, in our diagram we had suction height and delivery height. In this case, these are going to be our displacement distance, whereby the total displacement is going to be given as hs plus hd. Okay, so in our next slide we are now going to define work, whereby we said is the force times the distance. Now the force, which is the weight of the fluid being displaced, is given by gravity acceleration times density times the volume. Now in order for us to get the work, then we have to product it by the distance, which is suction head plus delivery head. Okay, I hope that was clear. Now let's say the pump is running at n revolutions per minute. Okay, so what is the power developed by that pump? You remember that we said that power is the rate of doing work. Now all we have to do is to take the work, multiply it by the rate of doing that work, which in this case is n over 60. The reason we are dividing by 60 is because we have it per minute. So, and we all know that the SI unit of time is second, so we have to divide it by 60. Now the final equation of power will be given as density times gravity times the L, which is the bow stroke or the length of the cylinder, multiplied by the revolutions, which is in this case is N, multiplied by pi d squared over 240, which is a product of 60 by 4, and now multiply by the displacement, which is in this case hs plus hd. Thank you for watching the video.